started, please don't forget, please subscribe to my channel, support my channel, Step-by-Step Science. You can get all my excellent physics, chemistry, and math videos. You can give me a comment on this video. You can give me a thumbs up. You can subscribe and you can share. Thank you very much. What is heat? Heat is the flow of energy, or we like to say heat is energy in transit. And of course, if it's flowing, it's got to be flowing somewhere. And if it's in transit, it's got to be in transit from one place to another. And where is all that heat going? Well, that heat goes from areas of high temperature to areas of low temperature, or objects with a higher temperature to objects of a lower temperature. Okay.
The question now, Abdul Mohsen.
Yes, mister?
The heat energy travels from warmer area to cooler area, or the opposite?
Opposite. In reverse.
From cooler to warmer?
Yes.
Sure? Like if you catch like a hot drink in your hand.
Yeah. No,
then
no, I mean from
warmer?
Yeah,
From warmer object to the cooler one.
Because mister, like when you have a cube of ice and you put it in your hands, you're taking the cold temperature from the ice to your hand and you're giving it the heat temperature.
No, the opposite. In this case, the heat energy transfer from your hand to the cool cup.
Yes, but mister, also the cold ice transferred the cold temperature to us.
That's why if you hold like a piece of ice in your hand, it will melt. Why?
Yes.
Let me ask Manaf this question. Manaf, if you have a piece of ice in your hand, what will happen to it after 2 minutes?
What?
If you have a piece of ice in your hand, if you carry it on your hand, what will happen to this piece of ice after 3 minutes?
It will melt.
Why?
Because it's solid.
I know it's solid. Why this solid transfer or change to be liquid after that? Why?
Because the heat.
Because heat energy from your hand transfer from your hand to this piece of ice. So from warmer object to the cooler object.
It's when I touch it, it became low temperature.
That's why the video said here from high temperature, the blue one, to low temperature, the red one. Thank you.
Okay, so that is the direction that heat is going. So we have a nice little definition we can use for heat. Heat is the energy transferred between objects due to differences in temperature. Okay, so heat will only flow between two objects if they have a different temperature. Now there's some things we have to be careful how we use heat or use the term heat. We don't like to say that objects possess heat. We don't like add up and say, oh, this object has so much heat. We don't say that because objects don't really have heat. Heat is a transfer of energy, so therefore objects possess or objects have energy, internal energy, but not heat. A lot of times I ask my students, well, how do we raise the temperature, or how do we lower the temperature? How do we freeze something or condense a gas into a liquid? And they'll say things like heat it up, cool it down, put it on the stove, put it in the refrigerator, freeze it, like that. But that's not how we do it. If we want to heat something up, we add heat. If we want to cool something down, lower the temperature, then we want to remove heat from that object. Okay, so that's how we like to talk about heat. Heat is the flow of energy from high to low temperature. Okay, now we did say that in order for heat to be transferred from one object to another, there has to be a difference in temperature. So here we have two objects. One is a larger object and one is a smaller object. Now you might think the energy might flow or something because this one is much bigger, but they're at a higher temperature, and heat will only flow when there's a difference in temperature. So we have a system with two different objects, or we have a system with two objects. If they're at the same temperature, then no heat will flow between those two objects. The bigger object might have more energy, might have more total energy, but no heat will flow between those two objects. So in order to get heat to flow, we have to have objects at different temperatures. So here we have a big object at 20 degrees Celsius. We have a smaller object at 50 degrees Celsius. And heat is always going to go from areas of high temperature to low temperature. Once again,
Okay, Yusuf,
Yes.
look at these two objects. The red one is the big object, and the small one, the blue one, is a small object. But here and for the red object, the temperature is 20 Celsius. For the smaller one, it's 50 Celsius. From where to where does the energy, the heat energy, move?
From the 20 Celsius.
From 20 to 50 or from 50 to 20?
Is it 50 from 20?
Yeah, from 50 to 20. That's right. If you remember, Yusuf, we said the heat energy transfers or moves from the warmer object to the cooler object. So what is warmer now, 50 or 20?
20.
Warmer, hot, hot.
Wait,
The hot
how
one?
is the ice?
Listen,
hot?
it's not ice. It's not ice. It's only cube.
The blue is heat?
Yeah, because it's 50 Celsius. It's higher than 20. You know?
I don't know about Celsius much.
Yeah, you know what is thermometer?
Everyone knows the thermometer.
You don't know what is thermometer?
No, I said everyone knows it. The
Yeah. So when you use a thermometer, it begins from 0 Celsius to 100 Celsius. You know, if I want to find your temperature, I'm talking about Yusuf now. Your temperature is about 37 degrees.
And you're gonna find out my temperature from the thermometer.
Yeah, that's right. You know, if I want to find the thermometer, the temperature of the boiling water, it's 100 degrees Celsius. And for freezing water, I'm talking about ice, it's about 0.
0 Celsius.
Now,
0 Celsius.
Now what is warmer, the red one or the blue one here?
Blue one.
The blue one. So the energy, the heat energy transfer from
the smaller object to the bigger object.
That's right. Thank you.
Again, sometimes people, oh, this is bigger. Well, you may have more internal energy, but the heat is going to flow from high to low temperature. So it's going to flow across from the 50 until the 20 until they reach the same temperature. All right. So we like to say that the transfer of energy from areas of high temperature to areas of low temperature, that is heat. Okay, maybe a couple little specific things about heat. When we do some calculations and talk about heat and write some stuff down, we have to remember that the equation symbol for heat is delta Q. Really, it's just the Q, but since heat is always being transferred from one place to another, we're usually talking about the changes in heat or the changes in energy due to the flow of heat, or the change in heat due to the flow of energy from one place to another. So we use the symbol Q, and delta means the change in, so that's the change in heat. The unit, the SI, the metric unit, is the joule. Okay, that's the international symbol for the unit for, that is the unit for heat is the joule, and it has the abbreviation J. It's the same energy, same unit we use for heat and energy, and also for work. Okay. And so, for example, we could write it down like this: delta Q is equal to 1500 joules, or the change in heat is equal to 1500 joules. Something gained 1500 joules of energy. All right, so that's that. And now we have another unit we commonly use. Now we did say that
Welcome to What is Heat? Let's start with an illustration. Here we have hot and cold blocks of some material, and they each have a thermometer in them to prove the point. If we put them together, what's going to happen to the temperature of the cold block, and what's going to happen to the temperature of the hot block?
Jamal? Jamal?
Yes.
Jamal, by what device can we find the temperature of the items?
The thermometer.
Thermometer. And it's labeled from what degree to what degree?
I never saw one in real.
You never see and in reality, you never see it?
No, never.
Oh, so let me show you what is thermometer, okay?
I only when I have fever, there's like something and it's like teet teet teet.
Yeah, it's like that. Look.
It's not the red liquid.
You're feeling
thing.
woozy. Maybe your forehead feels hot. You stick a thermometer in your mouth, but it comes back 37°C. Or it comes back 38°C. You're running a fever, call in sick. But if it comes back at 40°C, get yourself to the ER. We have a lot of confidence that we're measuring temperature accurately. 1 or 2 little degrees can literally mean the difference between calm nerves and a medical scare. Knowing temperature is important beyond your health too, whether it's setting the grill for the perfect burger or figuring out what hot outfit will keep you cool at a summer cosplay event. You can often proceed informed because of our trust in modern thermometers. If I told you thermometers don't measure
But we are warm blooded.
find your trust shaken?
What they say?
But we are warm blooded. How do we tell the difference?
You will know now. Look.
Thermometer means measurer of heat, but that's the same thing as temperature anyway, right? Well, scientifically speaking, no. But knowing about heat can tell you about temperature if you're clever. Temperature describes the average energy of the molecules in a system, while heat describes the transfer of energy between systems that are at different temperatures. Thermodynamics tells us how heat moves around in its first 3 laws. 0, heat is the same regardless of how it's measured. 1, heat cannot be created or destroyed. And 2, heat moves from hotter to colder. Yeah, that list starts at 0 because that part was figured out after 1 and 2. Anyway, armed with these laws, we can understand how thermometers work.
Look, Jamal, this is a thermometer in reality. You said before?
But I see it I see it in like science books like that.
You saw in the sign book?
Yeah.
Yeah. So the thermometer begins from 0 to 100. So the degrees here is different, a little bit different.
But I never touched it.
Yeah.
To us as possible. Consider the bulb type, that liquid in a glass tube thing you know and love. Imagine it's in the freezer. The thermometer loses heat to the surroundings. That means the molecules in the liquid slow down, and the liquid contracts, pulling its level down the scale.